Welcome everybody to our final lecture of the semester. Today we're just going to go through deleting a node very quickly. I'm not actually going to dig into the code because it's not vital to finish the lab in order to understand that. So we'll talk through it real high level, and then if you want to dig into it a little bit deeper, you can do that, looking at the code, running the programs, and then obviously sending me any sort of emails with questions that you may have. So we'll look at that real quick, and then we'll look at the lab, and I'll give you some hints, some pointers, some common errors that I've seen in the past in order to complete the lab. On top of that, you'll see in code here, while I'm not providing you a template for this one, obviously the stuff that we do look at, which that's the wrong, this is it, we'll look at this file here in a second, you will be able to pause it and copy out of here, okay? But let me talk through this here in just a little bit. So we'll go back to our linked list program. So this is the same linked list program we've been looking at now for the last couple lectures. The final thing that we'll want to do on a linked list is delete. Okay, so if we come up to our main program and we just make some minor modifications and we add CAF, at this point in time you have two versions of the insert. You have one that just inserts the new nodes at the end and one that maintains a sort order. It doesn't matter which one you use. Same with the lab. You can use either you can really use either version of it. It really doesn't matter. If the more advanced version is just too much, then just go back to the original version, the first version that we looked at, the one that doesn't care about a sort order. But at this point in time, it doesn't matter. Right now, I am using the one that maintains a sort order, okay, alphabetical ascending. So even though we create CAF, you'll see it as a CF. So we'll create that linked list, we'll print it off, and then what we'll do is we'll delete. Okay, so how do we delete? You can see here, first argument is a node pointer start pointer. Okay, so that means we have to have the memory address to our root node, and what do we want to delete? Okay, so in this case, I'll just delete the A. And then after that, we'll call print list again on our root node. Okay, so let's save that, we'll run it quick, and we'll see what happens. Okay, what was the error? Okay, A is undeclared. That's true. I used it as a variable. It's not a variable. I need to pass a char to it. So I'll wrap that in single quotes, and now we should get rid of those compilation errors, which we did. And now if we run the program, there you see. Okay, we had linked list ACF. We deleted it, and now, well, and we even have some output. A is removed, and now we have CF. So how does delete look? There's a few slides in the slide deck you can look at that helps. Maybe walk us through that process in a little more detail again, because I want to get to the lab, the final lab, and talking you through that. And because this week with the linked list topics, it can be quite a bit, we're just going to kind of gloss over it. Again, it's not critical to get through the rest of the semester to understand exactly how the delete function works, but if you spend some time with it, I think you'd see it's going to be pretty similar to the other functions. We're going to borrow a lot of the same code, the same logic, and it's not doing anything really all that complicated. So here is the delete function. Previous, current, and temp. Okay, so we're going to have previous and current, and we're going to use those in much the same way. That is, we need to know a current node, and we need to know a previous node. Okay, we also have the temp, and we're going to use the temp to store a temporary value in order to delete and actually delete a node. The first branch of logic here, okay, so we have two primary if-else branches. The first branch, if value is equal to the data member of our start pointer. Okay, so that simply means is the root node is the character that we're trying to delete in the root node. Okay, this program, this algorithm here, this function, it doesn't delete every single instance of. So if you have a linked list and it has 3 A's, it's only going to delete the very first. And if the very first instance is the root node, that's what this branch handles. Okay, so let's just say that's the case. The very first node in our linked list is the value that we want to remove. So the first thing we do, we have our temp pointer. We assign the memory address of that root node to that temp pointer, because that node that we've now identified is the one that we want to delete. What do we need to do with it? We need to deallocate the memory. Okay, well, we need a new root node. If the root node's going away, then our root node, root pointer from above still needs to exist. It still needs to point somewhere, otherwise our program's going to break. So we set it, the start pointer, the argument to our function, equal to its next node member. Okay, a root node will have a next node member, and that's the next node in the list. And in this case, we're now going to remove that root node and link itself to its next node member. Okay, so now we're saying, well, the root node no longer points at the root, it points at the next node. Now that we've created that link, okay, and only after we've created that link do we free our temp pointer. So the memory address that was allocated to that root node is now free, it's removed, and the function is done. And that's all we have to do. Okay, start pointer points to the next node, everything will still work. If that's not the case, we go down the else branch. Okay, if the root node isn't something that we need to remove, then we need to create some logic very similar to our insert function. And that is that we need to look through our linked list until we find the node that has the data member that we want to remove. Okay, so we're going to use previous and current much in the same way. We're going to have our while loop, again, a lot like the insert function. We'll have an additional condition with our logical AND. The only difference is we're going to continue to iterate until we find the value that's equal to the data member. Once this equals this, once this data member of whatever node we're looking at is equal to the value, then we know we found the value. We need to stop iterating. Okay, so we stop. Previous pointer and current pointer will be assigned appropriately. Current pointer being whatever node we're currently looking at, and previous pointer being the node right before that. If current pointer is equal to null, it's not equal to null, then we do pretty much the same thing we just did up in this first else if branch. We set temp pointer equal to current pointer is what we're going to remove. The previous pointer, because current pointer is going away, that node is no longer going to exist, the previous pointer, its next node member, needs to point to or be assigned the value of that current pointer's next node member. If the current pointer is the end of the linked list, that'll be equal to null, we'll have a new end of the linked list. If the current pointer's next node member is in fact another node, well, now we've created a link from that previous node to the next node, freeing up that current node to be deleted. Okay, once we make this link, that keeps our linked list intact. We can free the memory for that node, print that we removed it, and now we're done. Okay, so I know it's kind of hard to visualize this just looking at code, but because, like I said, I don't want to spend a lot of time on it. Let's see, how much time have we spent? 7 minutes, yeah. I don't want to spend any more time on it. If you want me to go through it in more detail, send me an email, and what I can do is I can either generate another lecture, or we can just talk about it together. We can do a Google Hangout or a Skype or just over email. So I'm going to leave it at that, though, and we'll move on. All right, so here's the lab. The lab opened up last week, and you had the ability to start kind of working on it. But now we'll go through, and I just want to point out some things that I think will help make it a little bit or maybe a lot easier. So the whole purpose of this lab is to create a copy of a linked list in reverse. And this doesn't just mean that you're going to print the linked list in reverse. This means you're going to create an actual copy of it. And so oftentimes what I'll see when students try to do this is that they'll create a function. They'll create the function as it's outlined in here that I want you to create. Excuse me. And they'll just print it off in reverse. And while that in and of itself isn't necessarily trivial, it's not the point. The point is to create an additional linked list. What does that mean? Well, when I show you some sample code, that hopefully will make sense a little bit more. Return type is a node pointer. Okay, so what does that mean? That means that your return value from this function you're creating, this reverse function. Well, hold on. Let me just start at the beginning. I'm sorry, I kind of jumped ahead a little bit there. Okay, so we're going to use the code that we've developed in class for linked list. Okay, so we're going to use the code that we've been talking about. You can use the main structure of it, you can use the structure itself, and then you can use the print list and the insert function. So using that code, I guess I have provided you with a template because you're going to use that code. You're going to create one additional function and then the appropriate modifications to your code in your main function. Your additional function, custom function, will be a reverse function. The purpose of that function will be to create a copy of the linked list with the nodes reversed. Okay, once that function's done, there'll be no printing in that function. It'll return the memory address to the beginning of that new linked list, and then we'll be able to print it off. Some restrictions on the function then. Okay, its return type is going to be a node pointer. So that means that reverse function that you're going to create will return a memory address because we're going to assign the return type to a variable of node pointer. It's going to have one argument. That'll be a node pointer as well, and that's going to be the value of your root pointer. Okay, and again, we'll look at this in code, so if it's not making sense yet, it should make sense by then. Make sure you return the correct memory address. Do not print anything in here. I'm just simply looking for the logic to reverse it and create a copy, create the copy in reverse, and then return that starting memory address. You really don't need that many lines of code. Okay, I say there's about 17 lines of code just to give you a rough estimate. If you're coding away and you have 50 or 60 or 70, you're doing something wrong. You're putting too much effort or too much code into it. Okay, it's about 17 lines of code, and that includes some comments and some spaces. Okay, in that code, you only need one loop, and the loop, all that loop needs to do is walk from. Okay, so you'll have the linked list that you pass in, and then the linked list that you're creating. All that loop needs to do then is walk that linked list, walk the list that you're making a copy of. As it's walking that list, create the copy and make sure that it's linked up appropriately. Okay, so it's really, there's not a lot of code that goes into it. It may be very abstract and hard to get your mind around it. So I would highly encourage you at this point to, maybe if you're not sure where to begin, start on paper. Okay, what do you need to do? And just draw it out in the simplest terms you can, and then start to build some code around that. Okay, so a lot of the logic's the same. It's nothing new. You just have to piece it together in the correct format. Here's some sample output, and the purpose of this first sample output is so that you can see here is the linked list that we entered. Okay, so A, B, C, D, E, F, G, H, I, J, and then it's null terminated. And here is the list in reverse. Okay, what I meant to show here, and it doesn't quite come through clearly, is that this value here, the memory address assigned to this J, the node that has a value of J, this is not the same memory address as this. These are not the same nodes. Okay, this and this are two separate nodes. They contain the same value, but they're two separate nodes. Okay, and then this is a function prototype for the reverse function. Okay, so when I say that it's going to return a node pointer and it has one argument, node pointer, this is what I mean. Okay. All right, the code itself. This is my solution for linked list. Of course, we'll look at everything but the actual reverse function. Here you can see we're doing our char data. Okay, so it's the exact same file that we've used for the last couple weeks now to look at linked list. Print list, exactly the same. You don't have to do anything there. Insert, exactly the same. You don't have to do anything there. You can use either version. You can create it in an alphabetical order, or you can just have it create the linked list as you go. It doesn't matter. The only thing that matters is that you have a reverse function and that it creates an in-memory copy of the linked list that you pass to it. All right, as far as the main goes, what you need to do then is just like we've been doing. Let's create a single root node. Let's set its next node equal to null. I've got code. What this program will do is it will take input from the user, so it'll take all these characters from the user and assign them to a variable, and then update the linked list, the nodes, and print them off. You know, I don't really care if you do scanf. I know that's in the lab. Excuse me, and this is how we're doing it here. All I care about is that you reverse it. So if you want to hard code values, if you want to create a node, insert them in manually, don't take any input from the keyboard, from standard in, that's fine. You know, all I care about is the reverse function, really. So you can do this if you want, but you don't have to do that. All I care about is that we have a linked list with 10 characters. Okay, so to go back to this, again, there's some limitations in how we work with linked list, and so what this code is doing is we're mallocating memory for the root node. We're setting its next node member equal to null. Then I'm setting up an array to capture all the chars from the user. With scanf, we can do something like this and say, enter 10 characters, each one separated by a space, and then assign those characters into the 10 elements of that array. Now that I have the characters, I go back and on that root node, I update its data member to the very first element, and then I simply created a loop here. And this loop starts at 1, and then it goes till 9, and it just finishes inserting each character from that array into that linked list. Okay, root is my root node, and I use that for all 9 inserts. Okay, so then after this code is done, so this chunk of code here, I print it off, and you'll see here that I have a 10 node linked list. Okay, so now to get into kind of the core of what I want you to do, again, I don't care how you get here. All we need at this point, once we get to this point in the execution of this program, we just need a linked list with 10 nodes. We want to make a copy of it. Okay, so I'm going to create another node pointer. Nothing new there. We create it just like we did a root node or the second node or anything, another node that we've created. We'll call our reverse function, passing it root, okay, because root is the linked list up here I want to make a copy of. And then we'll print list copy and we'll print list root. And what you should have then is that when you print copy and you print root, well, what you're going to see when I run this program is you'll have the original, we'll have the copy, and then we'll have the original again. And then what you'll see here is that they're two different linked lists, right? This is a copy, this is a pointer. This function is going to return a memory address. We're going to assign it to that pointer, and then we're going to provide the value of that pointer to our print list function, and that's going to print it off. This is what's telling me that you created it in memory. You created an actual copy of the linked list. Okay, so let's take a look and see how that runs. Okay, again, you don't have to worry about doing input. You can just hard code a linked list in, that's fine. Okay, so there's the original linked list. Okay, that's what I typed in. Here's the reverse, and then there's the original again. Okay, now the reason I'm printing off the original again, and I would encourage you to do the same, is because I've seen students oftentimes they'll actually go in and they'll figure out a way to reverse this linked list. And so they won't create a copy of these nodes. They'll change the order of it. They'll print this one, then they'll they'll reverse it, not without making a copy. So then they'll print that reverse. But because they didn't make a copy, if I print that original linked list again, it's in reverse now. And so they didn't modify it appropriately. So what this output is showing that we print the original, we print a reverse, a copy of it in reverse, and then we can print the original again. The original's still intact. Okay, so print the original, print the copy, print the original. And that, again, that's helping me to know that you did in fact create a copy of it. Let's see. Print, no output is generated except for these print list calls in main. Okay. So again, all the code's there. All you have to do is implement the reverse function and then print off the original and print off your copy. All right, as with any other labs, this one is probably going to be, well, okay, as with any other labs, if you run into any issues, this one isn't designed to stump you, but it is designed, I think, to make you think a little bit more. And so if you get stuck, don't spend any exorbitant amount of time on any one issue. Send me an email. Let me know and I can help you out, point you in the right direction. I would rather provide some assistance and have you get through the lab than to have you get stumped one place and then not be able to complete it. You can use then, again, just a reminder, use the code that we already have. Use that linked list code. You just need to implement the reverse function. Okay, so you don't have to write a lot of code here, but it can prove to be maybe a little bit challenging. One more thing, just a walkthrough. I found that this helped, at least on campus, is let's see how, if we have, let's say we have a linked list, and we'll just take a portion of it from what we were looking at, and in that linked list is ABC, and I want to create a reverse of it. Okay, so these are nodes, each one has its own memory address of some sort. They're not sequential, and this is the original. Okay, now if I want to create the copy, then ultimately what I want is I want C, I want B, and I want A. These are new nodes though, so they're going to have their own memory addresses. Again, memory addresses here, they're just completely arbitrary and trivial and they don't actually map up, but the point I'm trying to make is that they're not the same. This node was allocated memory, you got to assign the memory address of, let's just say 32. We want to create the copy. We need to copy the value, but we don't copy the memory address. We allocate memory for a new node, copy this data member over, but now we're creating a new linked list. I said that we're going to use a lot of the same functionality from what we've previously talked about. Okay, so how do we do this? How do we think through this process? And get rid of all this stuff. obviously what we need to do here, as we create a copy of this, we need to walk over every single node, one node at a time. With that then, we already have the functionality, we already have the logic to do that. Our print list is one. That one would work well. While the next node member is not equal to null, we have another node. And we have a pointer, then we can assign that to a pointer and we can access the data member. So what do we need to do then with each iteration? Well, with each iteration, we need to, one, copy the data. Well, before we can copy, we need to malloc a new node. We need to copy the data from the existing node into that new node. And then, with the new node, we need to make sure that its next node member is linked. Okay, and this is probably where it's going to get the trickiest. And so just think through it. Okay, when you're copying, you're going in this direction. As we're making a copy, we're creating the nodes essentially now in this direction, because this is the first node in the original. This will be the first node in the copy. That means that we'll create, in the copy, we'll create the root node last. And so you're going to need something like a previous and current pointer, but you're not using them in the exact same way that we've used them before. So that is probably the part where it'll be a little bit, well, that is the part where it is a challenge. Okay. So again, hopefully this helps. If not, let me know, and I'd be more than happy to help out. Hope everyone had a good semester, and definitely hope you guys learned something along the way. Student opinion surveys will be out there, and please, again, take a moment to fill those out and let me know what you think. And again, if you have any questions either now or in the future, I'm always available. Just send me an email and we can chat. All right. Hope you enjoy the rest of your semester. Thanks.